Welcome, Math 103. We're working on section 4.3 today on the multiplication of polynomials. Take a look at the introduction. A landscape architect is designing a landscape for a client. And the clients want a grassy area. And they know they want that grassy area to be at least 20 yards by 30 yards. But they like the biggest area they can afford. And they like to know the maintenance cost. So a landscape architect is going to design an equation that's going to calculate the maintenance cost for larger areas of grass. And the clients will be able to select whatever they can afford. We're going to learn how to set up and solve equations like this today. Let's start with a warm-up. So here we got a number outside parentheses. So whenever you see this, think distribution. We're going to distribute the 3 into all terms inside the parentheses. All the terms are the things that are separated by addition or subtraction. So we have two terms, 2x and 5. So we're going to multiply 3 by 2x and 3 by negative 5. And we get 6x minus 15. Now here we don't have distribution, we're just multiplying two monomials together. So just like we did last time, we're going to multiply the coefficient by the coefficient, right? Number by number. 4 times negative 3 is negative 12. So that becomes the coefficient of the product. Now we're going to use the properties of exponents to multiply x squared and x to the 5th together. So to multiply, we're going to add the exponents. 2 plus 5 is 7. So we get x to the 7th power. Negative 12, x to the 7th. Now we're going to extend this idea into larger and larger polynomials inside the parentheses. So here's our first example. We're going to distribute negative 3 into this polynomial. So when distributing just numbers, we're going to multiply numbers by the coefficients. The variable parts will stay exactly the same. Negative 3 times negative 2 is positive 6. So keep the x squared. Negative 3 times 4 is negative 12. And keep the x. Your turn, number 1. We're distributing, this time, a positive value in, so that will not change the sign on any of the terms in between. Notice in the last one, we distribute a negative in, and we change from negative to positive, positive to negative. But here we're going to keep the signs the same. 4 times negative 3 is negative 12, so we get negative 12x to the 3rd power. 4 times negative 7, negative 28, x squared. Now we're going to distribute in something with a variable. So we're going to have to keep in mind the properties of exponents. 2x times x, the coefficient here is just 1. So we got 2 for the coefficient. X times x is x squared. Now we're just multiplying by a number, so 2x times 4 is 8x. Variable part doesn't change in that one. Your turn, number 2. We're distributing 3x squared into this polynomial. We're going to multiply 3 times 5, right, coefficient by coefficient, to get 15. X squared times x. Add the exponents to get x to the 3rd power. Now in the second part, we're just multiplying by a number. So we got 3 times negative 9 is negative 27. And the variable part stays exactly the same, x squared. Now we can distribute into polynomials with as many terms as we want. The procedure is the same. So we're going to distribute negative 3x into here. That's going to change the sign on all these. This one will turn positive. Negative 3 times negative 3 is positive 9. X times x squared, x to the 3rd power. Now we'll do negative 3 times negative 2, that's positive 6. X times x is x squared. Now we're multiplying by 7. Negative 3 times 7, negative 21, x. Your turn, number 3. Now we're going to distribute negative 4x into this polynomial. So that'll change the sign on all these. This one's going to turn from positive to negative. Negative 4 times 2 is negative 8. X times x squared, x to the 3rd power. Distribute into the next term. Negative 4 times negative 3 is positive 12. X times x is x squared. Lastly, Negative 4 times negative 5 is positive 20. And we have no variables over here, so that remains x. Now just to make sure we change all the signs correctly, positive to negative, negative to positive, negative to positive. So we're going to distribute into a little larger polynomial now, 4 terms. So I have to do 4 multiplications. First by 3x to the 5th. Negative 4 times 3 is negative 12. X to the 4th times x to the 5th. Add the exponents to get x to the 9th power. Now we do negative 4 times negative 2. That's positive 8. X to the 4th times x to the 3rd. X to the 7th power. Negative 4 times positive 4 is negative 16. X to the 4th times x is x to the 5th. Then we got negative 4 times negative 8, which is positive 32. And no variable parts over here, so we just keep the x to the 4th power. And that brings us to your turn number 4. All right, so we'll distribute in negative 2x to the 3rd. So we'll do coefficient by coefficient. Negative 2 times 3 is negative 6. X to the 3rd times x to the 4th. X to the 7th. All right, next term. Negative 2 times negative 5 is positive 10. X to the 3rd times x to the 3rd. Add the exponents to get x to the 6th power. Negative 2 times positive 4 is negative 8. X to the 3rd times x squared. X to the 5th. Negative 2 times negative 8, positive 16. X to the 3rd times x is x to the 4th. Then we got negative 2 times negative 6, negative 12. And keep the variable part here, x to the 3rd power. So that's about all there is to multiplying monomials by polynomials. It's just distribution. Keep in mind your properties of exponents. Always got to have those. Now we're going to multiply 2 polynomials. So the idea when multiplying 2 polynomials together is we need to multiply every term of one polynomial by every term of the other polynomial. So that means we're going to be multiplying x by all three terms and then -2 by all three terms. So I'm going to start with the x. X times x squared, x to the third. X times 3x, 3x squared. X times 1 is x. All right, so there's x multiplied by all three of these. Now we'll do the -2. -2 times x squared is -2x squared. -2 times 3x is -6x. -2 times 1 is -2. Now notice that we have 6 terms. We should have 6 because what we can do is take 2 terms here, 3 terms here, multiply them together. 2 times 3 is 6. So we should have 6 terms. All right, now we can combine like terms. We have 2x squared terms, we can combine those together. Keep the x to the third, nothing to combine that with. 3 minus 2 is 1, so we get a single x squared. Now we can combine the x's. 1 minus 6 is -5, so minus 5x. Nothing to combine the 2 with, so tack on -2 on the end. And there's the fully simplified result. That's how you do it, just straight up by hand. We could also do this using a table. Some people like to use the table, helps keep things organized. So what we do in creating the table is put one of your binomials here, just one term in each block, and we'll put the other polynomial over here. So you have an x squared, a 3x, and 1. Now notice we have 6 answer blocks. So we'll multiply, say, x by x squared, put the answer in their intersection here, x to the third. -2 times x squared, -2x squared. X times 3x, that's 3x squared. X times 1 is x. 3x times -2 is -6x, that goes here. 1 times -2 is -2. So I have each one of these terms I listed out here, each one of those goes in a block, and then we'll combine like terms just like we did before. You can choose your method. But with your term number 5, I would like you to use the table just to try it out. So here we're going to multiply 2x plus 5 times 3x squared minus 4x plus 6. So we'll fill up the answer blocks now. We've got 2x times 3x squared, 6x to the third. 2x times -4x, -8x squared. 2x times 6 is 12x. And we got 5 times 3x squared, so that's 15x squared. 5 times -4x, -20x. And 5 times 6 is 30. Now we can combine any like terms. So we've got a couple of x squared terms here and a couple of x terms here. So there's the like terms that we can combine. The other ones will remain as they are. So 6x to the third, 15 minus 8 is 7, so plus 7x squared. Negative 20 plus 12 is negative 8, so negative 8x, and positive 30 on the end. That brings us to your term number 6. Got 2 more to multiply there. Use either method. First one, I'm going to start with 2x and distribute the 2x into the trinomial. 2x times x squared is 2x to the third. 2x times 5x, that's 10x. 2x times 6 is 12x. Now I'll distribute the 3 in. 3 times x squared, 3 times 5x, that's 15x. And then 3 times 6 is 18. All right, now we got some like terms. Hang on. Missed a squared here. There we go. That should be 10x squared. 2x times 5x, 10x squared. All right, now we'll combine positive 10x squared and positive 3x squared. And the other set of like terms are 12x, positive 12x, and positive 15x. And we get 2x to the third plus 13x squared plus 27x plus 18. Okay, now we've got some that include some negative signs, so make sure you're very careful with the negative signs. 3x times x squared, 3x to the third. 3x times negative 5x is negative 15x squared. 3x times 2 is 6x. Now distribute the negative 4 in. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 5 is positive 20 plus 20x. Negative 4 times 2 is negative 8. All right, like terms. We got negative 15x squared and negative 4x squared. Then we got 6x and 20x. Simplify gives us 3x to the third. We'll combine these two, negative 19x squared. Combine these two, plus 26x minus 8. All right, now we got part C and D. I'm going to start by distributing negative 5x into this polynomial. Negative 5 times 3 is negative 15. X times x squared is x to the third. That would be negative 5x times negative 4x. So that's plus 20 x squared. Negative 5x times 7 is negative 35x. All right, now I'll do the negative 2. Negative 2 times 3x, that's negative 6, or negative 3x squared, is negative 6x squared. So we got negative 2 times negative 4x, which is positive 8x, and negative 2 times 7, which is negative 14. On the combined like terms, 20 minus 6 is positive 14x squared. Negative 35 plus 8, that is negative 27x. And negative 14 on the end. Now with part D, there's two different ways we can do it. We can either multiply this binomial times this trinomial, get some result, and then distribute in negative 3x. Or we can distribute the negative 3x into this binomial first, and then do this multiplication. I'm going to do it the second way. I'm distributing negative 3x into here first. Negative 3x times x is negative 3x squared. Negative 3x times negative 1 is positive 3x. Well, now we've got one that looks just like the last one, or pretty close anyway. So I'm going to distribute in negative 3x squared into this trinomial. All right, negative 3x squared times x squared is negative 3x to the fourth power. Negative 3x squared times x is negative 3x to the third. Negative 3x times 1 is negative 3x squared. All right, now I'm going to distribute positive 3x into this one. So that's positive 3x to the third power. Now 3x times x plus 3x squared, and then 3x times 1. All right, now I've got some cancellations here. So we've got negative 3x to the third and positive 3x to the third. So those cancel each other out. And we got negative 3x squared and positive 3x squared. Those cancel each other out. So the final answer is negative 3x to the fourth plus 3x. All right, next up, we're going to multiply two binomials using the FOIL method. All right, here we have two binomials. Binomial, bi means two, so there's two terms in each. Now we're going to multiply these out. And here's a little mnemonic device we can use: F, O, I, and L. So F stands for first times first. Multiply the first term in each binomial together. 2x times 5x. And we get 10x squared. Now O, these are the outer terms in the binomials. 2x times negative 8x. Or 2x times negative 8. So that is negative 16x. Now we'll do the I for inner terms, the two inner terms of the binomials. 3 times 5x. And finally, L is for last. 3 times negative 8. And that's negative 24. And the like terms will usually be the O and the I, with kind of standard binomials like this. It can change if we have different powers in there. we're going to combine these two like terms together. So we get 10x squared. Combining these, that's minus x minus 24. Your turn, number 7. Use the FOIL method to multiply those binomials. First one, f x times x is x squared. Outside, 5x. Inside, 2x. And last, 10. Combining the two middle terms, we get x squared plus 7x plus 10. Part B, f x times x is x squared. Outside, negative 4x. Inside, negative 3x. Last, positive 12. That gives us x squared minus 7x plus 12. C, 3x times 2x, that is 6x squared. Outside, plus 15x. Inside, minus 14x. Last, negative 7 times 5 is negative 35. Combining the two middle terms, we get 6x squared plus x minus 35. Part D, f x squared times x, that's x to the third power. Outside, minus 5x squared. Inside, plus 2x squared. And last, minus 10x. That gives us x to the third power minus 3x squared minus 10x. Now we're going to look at a special form. And we're going to see what happens when we multiply binomials with the same terms, but with a different sign in between them, different operation, addition or subtraction. So I'd like everybody to use the FOIL method now to fill out the table with binomials, first, outer, inner, last, and then simplify at the end. Combine whatever like terms you have to get a simplified result on the end. So we'll start off with the binomials x plus 1, x minus 1. All right, so same terms, x and 1, just a different sign in between, plus or minus. And look for any patterns developing here. And then the last one, we have no numbers in there, we just have letters. So we want to see what the general formula looks like. First one, f is x squared. Outside, negative x. Inside, plus x. Last, minus 1. So there's the terms we get when we FOIL. Now notice what happens in these two middle terms in all these cases. Negative x plus x. Combine them to get 0. Negative 6 plus 6x. Combine them to get 0. Negative 20x plus 20x. Combine them to get 0. Negative ab plus ab. Combine them to get 0. They all cancel each other out. So what we get is the first term and the last term only. X squared minus 1. 4x squared minus 9. 25x squared minus 16. And a squared minus b squared. So if you look at this last row here, that gives us our formula. A plus b times a minus b equals a squared minus b squared. And this is the famous difference of squares formula. So if you ever see two binomials multiplied like this for the same terms, different signs in between, you can go right to the formula, just write it down as a squared minus b squared. And this will be a very important formula to know, not only for this chapter, but when we go on to factoring, we're going to be doing this in reverse, going from this form to this form. All right, now let's use the shortcut in your turn number 8. Use this formula so that you don't have to go through and do the whole FOIL. Just find the first term squared and subtract the second term squared. All right, first one. First term squared is x squared. All right, by the formula, now we're going to subtract. Second term is 4. 4 squared is 16. So we get x squared minus 16 for that one. B. First term, 3x. When we square 3x, we square both of these things. Square root of 3 to get 9. Square the x to get x squared. Minus, second term squared is 1. So that'd be 9x squared minus 1. C. 5x, when we square that, square the 5 to get 25. Square the x to get x squared. All right, there's the first term squared. Subtract. And then we'll do b squared. b is 2, 2 squared is 4. So that gives us 25x squared minus 4. And the last one, first term is 2x. We'll square that to get 4x squared. Minus, we'll do 3y squared. 3 squared is 9. Y squared is, well, y squared. We get 4x squared minus 9y squared. So a nice little shortcut for that one. All right, now we're moving on to the application. We got our landscape architect designing the landscape. And with a problem like this, it's a good idea to draw a diagram. I have one on the handout for you. I'm just going to reproduce it here. So here's the potential grassy area. And inside here, this is the area that we know the clients want to be graphed. So we got 20 by 30 area there. All right, that's the minimum size of the grassy area they want. But they want a bigger one. So we might add on some unknown value to all four sides. All right, so we're going to take this grassy area and we're going to widen it out. So now we want to be able to find the maintenance cost of the potentially larger area. So first thing we need is to create an expression for the area. In order to do that, we need expressions for the length and the width. All right, here's the length. And here's the width. Now, using this diagram, your first objective is to create expressions for the length and the width of this outer area. Now, it can be hard to think in terms of variables. I'm going to create another little mini diagram down here. We still have 20 on this side, still have 30 on this side. And let's say, I'm just going to come up with some random actual number, that the width of this is going to be 5. So on all sides, we got an additional 5 here. If the additional width is 5, what's the new length and width of this outer area? Well, the width is 20, and then we have 5 here, so we got 5, 20, and 5. How do we get the total width? We add all those together. 5 plus 20 plus 5. And so we get 30. Now we can do the length. We get 5, 30 here, and then 5 more here. And we get 40. Right? So that's the basic idea of how to find the width of the outer area, given that we know the inner area and we know this distance as well. All right, let's apply that same idea to this. To come up with an expression for the width and the length. So the width, we're going this way. So we have x here, and then we have 20, and then we have x. So just like we did here, we're going to add all those together. Combining the two x's together, we get 2x plus 20. So that's the width. Now let's do the same thing for the length. We've got x, we have 30, and we have x. So the total length is x plus 30 plus x, which equals 2x plus 30. Well, now we want to find the area of this whole thing. Area formula is length times width. So go ahead and find an expression for the area. We'll plug in our expressions, 2x plus 20 for the width, 2x plus 30 for the length. Now we've got two binomials multiplied by each other, so we use the FOIL method. 2x times 2x, that is 4x squared. Outside, 2x times 20, 40x. Inside, 30 times 2x is 60x. Last, 30 times 20 is 600. Combining like terms, we get 4x squared plus 100x plus 600. Now we're given that it costs $2 for every square foot of lawn. All right, this is the amount of lawn we have in square feet. We're assuming all these measurements are in feet. So this is the area. If we want the cost, it's $2 for every square foot. That means we're going to multiply this expression by 2. That'll be the cost. I'm going to call that C. Cost is 2 times the area, which is 2 times this expression. All right, now we can take this 2 and distribute it into the expression. We get this cost function here, which is 8x squared plus 200x plus 1200. And the last question, let's find the maintenance cost if 5 feet is the distance we want to add on to each side. Well, 5 is x, so now we'll take x here and replace it with 5. We're going to plug 5 in for all the x's. So after we plug in 5 and evaluate it, we get 2,400. So that means it's going to cost $2,400 per year to maintain the lawn. That's it for today. Have a great day.